Right, I will be discussing Chapter P, Practice Number 4. The requested problems were 2, 11D, 14, 16, 18, 20, and 21. I'm doing them all in one video because it's a little bit easier for me, so just fast forward to the ones that you need to watch. All right, number 2 asks us to find all points of intersection of the graphs of x squared plus y equals 2 and 2x minus y equals 1. If we want to find points of intersection, we basically just need to find an x value and a y value where they cross. The first thing that I'm going to do is I'm going to solve, we could solve either one of them for y. Actually, I think I'll just solve this second one for y. So I am going to subtract 2x from both sides. So I'll have negative y equals 1 minus 2x. And then I do need to divide or multiply both sides by a negative 1. So I'll get y equals negative 1 plus 2x. And now what I can do, since I know y, I can go up into the first equation and actually plug that in for the y. So I'm going to have x squared plus negative 1 plus 2x equals 2. The next thing that I'm going to do, if I want to try to factor this, it has to equal 0. So I'm going to subtract 2 from both sides. If I put this in order, I'll have x squared plus 2x minus 3 equals 0. Then I have a trinomial that I can factor. That can be factored into x plus 3, x minus 1. And then my zeros for this would be x equals negative 3 and x equals 1. And then I do need y values to go with those, so I'm going to go back into this equation right up here. When x is equal to negative 3, negative 1 plus 2 times negative 3 would be negative 7, so my y value would be negative 7 for that one. And then this one, if I plug in 1, negative 1 plus 2 times 1 would be 1. So my 2 points of intersection for this problem would be negative 3, negative 7, and 1, 1. Okay, next problem that you asked about was number 11D. Let's see, the original function, 11D. The original function looked something like, I'm just going to try to, whoop, did not look like that. Oh my goodness gracious. Okay, looked something like that. Sorry about that. So something like that. I think this was down at negative 6. Okay, when it says negative f of x minus 4, remember f of x is like a y value. So we're changing the sign on the y value, and if you change the sign on the y value, that makes it x-axis symmetric. So this is going to flip over the x-axis. So if I were to flip that over the x-axis, it would now look something like this. It's still heading down at negative 6, or it still has that vertex down at negative 6. And then the minus 4 is going to force me to move the graph down 4. So instead of the vertex being at negative 6, it will be down at negative 10. So I flipped it over the x-axis, and now I need to go down, way down to negative 10. So it will look something like that. Okay, the next one you asked about was problem number 14. And we know that f of x equals 2x squared plus x minus 13. It asked us to find f of x plus delta x minus f of x over, delta x. So for this one, wherever I see, for this f of x plus delta x, wherever I see an x, I'm going to put x plus delta x in its place. So I will put an x plus delta x there, and I will also put one right there. So I'm going to have 2 parentheses x plus delta x squared plus x plus delta x minus 13. And then I have minus f of x. Well, we know that f of x is equal to 2x squared plus x minus 13. And I am going to put that in parentheses because we're subtracting that whole function. And it's going to be all over delta x. Next, I'm going to use Pascal's triangle to simplify that x plus delta x squared. I'll get x squared plus 2x delta x plus delta x squared plus x plus delta x minus 13. I'm going to distribute my minus, so minus 2x squared minus x minus 13 all over delta x. I'm now going to distribute the 2, so I'm going to have 2x squared plus 4x delta x plus 2 delta x squared plus x plus delta x minus 13 minus 2x squared minus x minus 13 all over delta x. Now I notice that my 2x squareds will cancel. My x's will cancel. My 13s will cancel because this was actually, should be a plus right here when I got rid of my parentheses. So the 13s do cancel. So I'm left with 4x delta x plus 2 delta x squared plus delta x all over delta x. I now notice in the numerator that I can factor out a delta x. When I do that, I'll get 4x plus 2 delta x minus delta x divided by delta x is 1 all over delta x. The delta x's now cancel. So I am left with 4x plus 2 delta x minus 1. This time we do not have to let delta x approach 0 because the problem did not ask us to do that. So that is my answer. Okay, next problem you asked about was number 16. Okay, here was the deal with number 16. If you tried to do number 16 and tried to graph it, you probably noticed that no matter what you did, you could not find this answer. So what I would like for you to do, if we're looking for a break-even point, we want to know where these two intersect. Okay, but we're going to make it a little bit more friendly. So what I'd like you to do is change that 10,000. Let's change it to a 100. So please go ahead and graph those. When you actually do this, if you press zoom 9, it will fit the graph to your problem. So you should be able to see where they intersect. And if you do not remember how to use the intersect feature on your calculator, please visit my video that's called Finding Points of Intersection Using Your Calculator. Okay, next problem was number 18. We're going to find the domain of f of x equals 5 over x squared minus x minus 72. Basically what we're looking for is what can't x be. I notice that I will get an undefined answer if my denominator is equal to 0. So I'm going to figure out what's going to make that denominator equal to 0. I do notice that that's something I can factor. That will factor as x minus 9 times x plus 8. So the two places would be x equals 9 and x equals negative 8. And I know that everything else will work, just 9 will not work and negative 8 will not work. So notice, although I could use my calculator on this one, I think this problem is just as easy not using the calculator. So if I'm listing my domain can be start at negative infinity, but I have to stop at negative 8 because it cannot be negative 8. It can be any number between negative 8 and positive 9. And then it can be any number from 9 to positive infinity. Notice I did not use brackets because x cannot be negative 8 and x cannot be 9. So that is my domain. Alrighty, next one we've got problem 20 and problem 21. Alright, I noticed these ones. I'm guessing if you had a question on these, it's because you don't remember how to find linear models and quadratic models on your calculator. So I'm going to, instead of doing these problems for you, I'm going to refer you to the P4 video notes. Those give you very nice ways to actually solve this problem. So if you are stuck and don't know how to type it in your calculator, please visit those video notes and you should get unstuck. So any other questions, I will definitely answer in class tomorrow.